The CivilFEM ACT extension is fully integrated into the Ansys Workbench and Mechanical environments. Upon loading the extension, the Checking and Design tool will be displayed. Share the Ansys model with the Checking and Design tool to create the system in Ansys Mechanical. In the Ansys Mechanical environment, our checking and design analysis will be available. Additionally, in the ribbon, there will be a new CivilFEM tab with buttons to create our objects. The first step is to create the CivilFEM tree. In Analysis Settings, we can define the general parameters used by the application. Among them, we can define the structural steel and concrete standards we will use. The materials will be defined from the CivilFEM material database. We can define structural steel, concrete, and concrete reinforcement materials. These materials will be used for the checking and design application, regardless of the materials used in the Ansys calculation. This is because these materials include specific standard properties, which can be edited by the user within each CivilFEM material. Structural elements are used to define the parts of the Ansys model that we want to check or design, and also to define the necessary properties for our calculation, such as the definition of reinforcements, sections, and specific standard properties. Concrete slabs and beams and steel beams can be generated. Structural elements are associated with the Ansys model through a geometry selection, which can be either by graphical selection or by name selection. When applying the geometry to the structural element, CivilFEM automatically extracts properties from the Ansys model, such as the thickness of slabs or the section of beam elements. For steel beam structural elements, it is possible to use the CivilFEM section library to define them. As with materials, the sections being checked are those defined in CivilFEM, regardless of those used in the Ansys calculation. Once the structural elements are defined, the next step is to define the Ansys load cases that we want to use for checking and design, and to define the combinations of these load cases. The datasets that define these load cases can be filled by selecting the resolved cases in Ansys through a window or directly through the Ansys result files. There are two ways to define combinations: user combinations or standard combinations. User combinations allow any desired combinations to be generated using combination rules and coefficients for each load state. In the combinations window, the previously defined datasets will be available. We can easily assign them to the combination and apply the coefficients to each load case. The other option for combining load cases is to use the CivilFEM standard combinations window. This window allows combinations to be created according to the Eurocode or the American ASCE standard. In the Load tab, we need to associate the previously defined datasets with the type of load they represent and define the coefficients for the various limits states and design situations. The Compatibilities tab allows defining if there is any incompatibility between the loads, so that they cannot act together in any combination. Finally, in the Combinations tab, we can see the standard generated combinations and filter them by limit state and design situation. When solving the CivilFEM analysis, the defined combinations will be generated. They will be reflected in the solution information. Lastly, we need to add the checks and designs we want to perform for the various types of structural elements. Within each type, there is a wide variety of available standard checks and designs. These are performed for all defined combinations and are displayed as another result in Ansys Mechanical. Thus, we can use Ansys Mechanical tools to export the results or evaluate the maximum across all combinations, to visualize the checking envelope. We can also evaluate the forces and moments obtained from the combinations, which are used for the checking and design. The checking results include both the overall criterion, which defines the ratio between the design forces and the section capacity, and intermediate standard results,